Yeah, let me do a quick intro.
Right.
So we have welcome everyone to SAS Engineering Talk. A couple of weeks ago, we had Jiten sort of telling us that you know we don't give mobile engineering teams enough love and affection, and I was also mildly sort of can be accused of that. I thought, okay, we've not had really any talks on that front in this talk series, and I got introduced to Arnav, and he's sort of helped put together a very nice talk. So Arnav is from Scalar Academy. He will cover common problems that mid to large mobile engineering teams face. Uh, this is a intro he's written. I am not saying this. Apparently, he gets mistaken for Arijit Singh, which is I cannot disagree with it. Uh, or not busy shitposting on Twitter. Arnav teaches people to build apps and websites. At Scalar Academy. In the past, he created Zomato's mobile platform team, and he used to lead Target's Android engineering team in India. So yeah, uh, please take it away, Arnav.
So hey, hi everybody. So this talk was like Siva was saying, I recently also sat down with Jiten on a podcast, and that episode was coming down next week or so, and we were talking about how sort of mobile engineering sometimes lies on the wayside, and then CTOs and all coming from a back-end background, usually because like if you are 20 years in the industry, you definitely would have not started off with Android or iOS because it did not exist. What happens is sometimes mobile teams get neglected, and it's even rare. Like pretty large companies, you might have a couple of VP of engineering type folks who are responsible for some of your core things like payments or ordering and these kind of things, and you still don't have actually a VP of engineering on mobile. Mobile is sort of thought that okay, there's this guy on mobile team who does something. That was Jiten was saying that that's how a lot of times it happens. So how can we sort of do mobile engineering better? That's we talked about. I obviously have not been able to get into each and every piece. I am not focusing on anything that can be more platform specific, like because I wanted to be covering things which would be easily applicable whether you're working on your app on Flutter, React Native, native Android, and all of that. It's more about the engineering decisions you take, the processes that you have. I have of course, very quick disclaimer right from the beginning that much of this talk is based on experiences I have had at Zomato and Target. So at Zomato, I started off leading the platform team. So I went into Zomato, and platform team got built around me, and then I was leading the mobile engineering team for a while. And then I was the Android lead on Target. Um, so these are fairly like large DAU B2C e-com type of apps. So maybe not all of the advice here might be applicable to, let's say you're creating a B2B dashboard for 5 clients or something like that. Maybe you have different concerns there. So that's just to keep in picture. That's what my personal biases could be. And in terms of tech knowledge, I mostly have worked with native Android. I have managed and led teams which are working on React Native and iOS as well. Personally, though, I only have expertise on Android itself. Now, for this talk, it's I try to keep it as small as possible so that we have time for questions and all at the end. Um, I've divided it into 3 parts, and then a fourth I have removed testability out because I feel like it should have its own place there. So first part is going to be about some engineering decisions. Second part is about org design for mobile teams. Third part is processes, which some of it might be common to other things as well, but still I'm trying to talk about what processes are important to enable a good mobile engineering team. And finally, testability. And then testing is an important thing because there are a lot of opinions around whether you should have 100% test coverage. Is it even possible to do end-to-end testing on mobiles? Will manual testing always be there? And testing is a little different here than like you create a test suite for a microservice. It's quite different here. There are a lot of different users who will be using it, and it will be out in the wild. It's not going to be your environment where it will always be running. So if sort of testability, some part of it is how you engineer, some part of it is how you design as well. But that's the final piece there. So in terms of engineering, I'll be covering four things. One is how scale is different on mobile. Then some engineering choices on your mobile apps, how you should modularize, what some decisions you should take about third-party libraries, and finally about how do you handle navigation deep links state, because that's sort of a very important part of how mobile apps are built. I have the chat window open. So while I'm speaking, if there's anything anybody wants to, speak, you can feel free to unmute and speak as well, and feel free to drop anything in the chat message. I'm happy to sort of break for a minute and take that question up and answer that as well. So, of course, I'd start off with the first part is that scale on mobile is a very different thing. So it's not like a mobile device is not where millions of requests per second sort of scale is going to be hitting you, because at the end of the day, one app is going to be running on one device only. So the scale is always going to be one in terms of users always for the app itself. But what happens with scale is the engineering challenges that come is a little different, which is that you would be, and especially for that's why I say a little bit bias of the B2C side. If you expand, you will end up in regions where you have low bandwidth, or commonly people use phones with low storage size, or phones where RAM runs out. They have 2 GB, 4 GB RAM phones. And you run into version fragmentation, which is a lot of people using different versions. iOS, it's a smaller problem. Android, it's a much bigger problem. Screen size and all of that stuff. Now, if you are, if you're ever on a content consumption app, this is something that you would know is that one of the very frequent user complaints is about that because of using your app, my data pack got over. And sitting in our cities and on postpaid plans, it's might not be able to empathize with that, but this is a very common thing that happens with any app that has scaled into hinterland of India, for example. It's a very common thing. EdTech and all, I have seen this facing a lot, that your video sizes are too large. While streaming, my data pack goes over, so I'm not able to cover the curriculum. Things like this. And it's very frequent. It's not an anecdote, a rare anecdote I'm picking. The other thing is, in a competitive field, like if there is exactly same product, 2-3 other people are also delivering along with you, your app size becomes very important in India, also in Southeast Asian countries like Indonesia and all, where your uninstall rates are very proportional to your app size. You reduce your app size, uninstall rates go down. We had seen that at Zomato. There's an article we published back in 2019, I think, where we talked about how while adding new features, we reduced our app size from about 22 to 16 MB. Our install rates fell down because of that. Now that said, there is also transactions per day or API hits per second. They are misspelled seconds are still important. And why that is because a good mobile engineering team is going to be able to create systems which help mitigate a lot of scale problems on the backend. Now, to take an anecdote here, this something happened in a team I was working was that we had millions of users using our app, and something happened like the payload that we are sending for logging, there was some problem with that, and that our logging system would keep on retrying, and it did not have exponential backup built in back then. And it sort of basically DDoSed our entire logging framework. That logging framework came down, and because internal services also used to use the same logging framework, they were not able to log. So we brought down the logging framework, and we brought down monitoring for our entire entire backend also for a while. So scale is when you actually hit scale, then on mobile you will have to do things like enable caching. You will have to sit down with your mobile and backend teams and develop caching strategies, which will have a lot of business context, product context also inside. And you'll have to create these mitigation things so that your users just by normal usage do not end up sort of DDoSing your own backend. So those things are going to be there. So scale is there in a different way in mobile, and you need people who understand that, and you need people who can build solutions around that. Right. Next is the about modularization, and this is I will actually come to the modularization, the same diagram again in the org design part. But when obviously you're sort of scaling up, lots of different features get created, and just like microservices happen on the backend on apps, also you would want to start creating modules. One way I have seen work very well in a lot of success I have seen is creating a sort of three-layer structure where you have your engineering utilities as the sort of bottom layer. So you have a network library, a logging library, a design kit, these kind of things. On top of that, you create another layer, which is your feature level libraries, which basically are one-on-one product ownerships in a way, right? And then all of these you put together into your app. And ideally, like if you start off with good modularization, your app is very thin. It's very much like that microservice kind of a thing. Either you start off with a monolith and you start pushing things out, or you start with an architecture in place. Now, what happens in apps where they migrate to modularization later on, obviously you start off with a big green box up there, and these purple boxes are sort of smaller pieces you slowly one by one start moving out. The end goal itself obviously is that your app is going to be one of the smallest modules. It's only be integrating things together. And if you use like dependency injection and navigation graphs, you can just move off control into the feature whenever user clicks on something, and your app does not have a lot of logic actually. The key to it is, of course, that your feature modules should never be dependent on each other. Like any of these purple modules in that layer, they should not have a dependency on each other. They can depend on as many number of engineering utilities because those can be used as many times as possible. Your engineering utilities then sort of become more like external libraries. You can end up actually versioning them as well. Like V1 of a networking kit supports so and so things. V2 of a networking kit supports extra things. It supports caching, which is not there in V1, stuff like that. And that's your sort of common engineering utility layer. I'll talk more about how this helps in terms of org design as well. But largely, this is a sort of modularization that even very big apps like Uber and Slack, Square, they also use something very similar. And also dividing up the code base. Another very important part about taking engineering decisions very early on with mobile apps is what do you do about third-party libraries. And what happens is like a very important thing to keep in mind is that you might, and this happens very frequently, especially if your app goes to a very high scale, you might be using a library whose author has not seen the sort of scale that you are seeing. Could be some guy writing artisan code sitting in Europe or America, and they probably are an agency and they have built apps for 10,000 users. And then you put their library into your app and you deploy it in India with 10 million users. What's going to happen is that their library's code will first time run on certain devices, certain resources that has never run before. So, and it's very common if you look at moderately popular libraries, you look at their issues, you will see that the library developers are figuring out new issues because the apps that are using that library are reporting them. Right. So it's a big risk you're undertaking whenever you're taking third-party libraries, and anybody who has been in the app ecosystem for a while, any senior engineers, you would find them extremely averse to third-party libraries. People literally like on Android world, I can tell you that accept libraries from Google and Square. Square is very popular because they've written a lot of very popular Android libraries for networking, retrofit, OpenHTTP, JSON serialization, and all. A lot of people have unsaid policies internally that no libraries other than Square and Google I am going to be introducing into my app. That happens a lot. Very recently, these are all like during pandemic. This happened. Like Google Maps SDK had about 20 million users were affected. Facebook login SDK had about 10 million users were crashing immediately as soon as opening their app. And these were crashes which were like people not using Facebook login for that app, but the SDK was crashing whenever the SDK was getting loaded, stuff like that. So it's very important to sort of know what you're getting into when you're using third-party libraries. Uh, Obviously, one option that a lot of people do take in larger apps is they, instead of downloading it from Maven or including it as a pre-built library, a lot of people add the library as a source for both things. Sometimes some people need to do some customization on top of that library. Other things is also like you can then run your whole thing through whatever security testing suite maybe your security team or compliance team has put into place. You can be assured that okay, my source code of my library is also sort of getting tested via that. You'll have to, sometimes people do it because their CI is not able to pull a third-party library from Maven or something, so they have to include it as a source itself. But yeah, of course, you take a build time hit a lot of times because of doing that, but you also get the ability to self-fix. So it's a sort of trade-off you have to see. I mean, option one is usually not using third-party libraries. Option two, sometimes pulling it into your source code if you really need it. You can also drop off unnecessary parts of the library, which with things like ProGuard and all can happen automatically also for Android, but nevertheless. Then a very important part, and I wanted to talk about here, is that these three things actually go hand in hand. But a mobile app, when you're building it, you are very much building a state machine. And the earlier you accept that, the better it is. The closer your navigation graph is to a pure state machine, you would be sleeping better at night. So essentially, a lot of people don't create the navigation graph in their head. Like if I take a step ahead, this is generally how a small app starts off. It's gonna how it looks like. You enter with a splash screen. You can go to login if you want to. You might directly go to home. From home, you can go to a bunch of pages. Some of them need authentication. Like you need authentication for profile. If you're not, the authenticated profile page does not show up. Shop, maybe you can go directly. You can go to blog directly, but support page, you need authentication. Otherwise, maybe profile and support, the way to go there does not show up. Let's say you go to cart, and then from cart, you might be able to, when you click on checkout, then you might have to log in again. So you are sent back to login page, and then from login page, you come back into checkout. Again, office checked when you go to the checkout page. The thing is that, very much like how we think in backend, that our controllers, they are purely stateless, and any request that is coming into a controller, you don't really know whether the request that's coming in is from a user who has just now made another request, right? So the sooner you move to a same paradigm in mobile, you would start living a better life. Where when you say, for example, designing the checkout page, you don't care whether the person is directly coming from cart or they have gone to cart to login, and from login to cart they're coming. You just know that okay, this is the input of checkout page, and I'm going to use this way. So then each of your pages basically they become a state in your state machine, and it really does not matter what is the previous state you're coming from, as long as you bring all the data that is required to the state. Building this navigation graph, whether you actually use a navigation framework to build it or you document this, lay it out somewhere and write the code accordingly. But the sooner you do it, it's going to be better because this is what your app is. You can keep denying it for a while, and your PMs will say, okay, click on this button, go to this page, and you keep on writing, patching code like that as much as possible. But the sooner you accept this, you're going to be way better off. And I will cover this thing again later on in testability, why this is important and how this can actually improve your speed at which code ends up on release. So that's about some of the engineering choices, which I felt like very mobile specific. You have to keep in mind, and the earlier on you keep in mind, that's good. Moving on to some org design choices, which are also very important. Karthik has a question, which is the best navigation library for Android apart from Jetpack app? So what I have personally felt is that rather than using a navigation library like Jetpack, design this in a DOM on your Confluence on a Markdown page, wherever. and then you code it out with intents. You know that, okay, this is the intent. These are the types of intents with which checkout page can open. These are the places where this intents can be thrown. And you create over time you can create your own navigation setup where you have functions which can be called to open a page, and that function takes in the items that are required. So like open checkout becomes a static function, and it takes in all the things that are required. Right? It takes if the cart objects are required to send into checkout, if user is supposed to be authenticated. So there are some things you can abstract out of the navigation graph, which is whether the user is currently logged in or not. You can create a separate service which looks at like the local storage where you might have the key of the user, or the user authenticated, the state of that, even dependency inject that at every place. So you can extract out auth away, right? For analytics, you might need certain parts of context like shop ID, store ID, these kind of things. So you can extract out your own context. Like Android has a context object, not confusing with that. You might have a context object where you keep what shop I am in, what product I have bought, what card I'm using, all these things you can keep adding to context, and so that your logs and traces go correctly. So you can extract some things out into common services that can be dependency injected wherever you want to, and then you write the rest of the part of the navigation. So if you feel like Jetpack navigation is too constraining, that's the case. One thing I suspect a lot of people think that Jetpack navigation is too constraining is because they're not creating this navigation graph in their mind, and then Jetpack navigation forces you to do that. And it forces you to do that, you feel like, hey, I want so many other things to come into my checkout page, but Jetpack navigation says that I can only send a keyword to pair. Why not force yourself to think that, yes, I can start the checkout page with a key value pair? It will improve testability, and I will cover that when I come back to this, and I will show this graphic. Any other questions in engineering? If anybody has, happy to take them. Moving on to some org design questions again, and some of them are very important in terms of designing a good mobile product engineering team, I feel. I'll of course pick up the first very controversial question, which is to QA or not to QA. I don't know, maybe you can we can create a poll here. How many people have like a full-fledged QA team are working actively one-on-one with engineers?
Actually, you can just probably answer in the chat itself.
Yeah, you can probably answer in the chat itself. What's the QA strategy? Do you have a full-fledged QA team? Do you have zero QA? What is the QA to engineer? So a lot of people, some people have QA teams. I'm seeing some people have, Vaidik say that they have test engineers working on test infrastructure and tooling. Vaidik, is this for mobile though, that you have test infrastructure working on infrastructure and tooling for mobile?
It's for the entire product end to end.
Is the entire, so for mobile, what sort of test infrastructure and tooling is a test engineer working
on? So it would be sort of, it would be definitely it would be things that involve end-to-end tests for the mobile product as well as the web product. In some cases where end-to-end tests, in fact, most cases where end-to-end tests become terribly slow, they sort of move towards platform level testing frameworks wherever the team has skills right now, and they're also building those skills along the way, because I mean it is clear that the product is so complex that you can't do end-to-end tests all the time.
Got it. So in a way, your test engineers are SDEs who create the infrastructure and not people who are responsible for running the tests.
No, so they write only essential tests for some of the key functionalities, but they're not embedded in pods. They sort of do that retrospectively.
Got it. So other people also I see manual for discovery and automation for regression. Ullas said. Honey, so obvious does not have QA, and Piyush said, okay. So I to talk about the QA topic, I generally talk about obviously the famous people recognize this code. It's called the fundamental theorem of software engineering. We can solve any problem by introducing an extra level of indirection. So this is the theorem that governs all of the adapters and builders and configurators that exist in all of your code bases. If anybody has not come across this, I would suggest you search this code and read about the book in which it exists, and a lot of discussions around that exist on Hacker News, around Reddit, everywhere. But there is a common extension to this problem, this statement, which is we can solve any problem by introducing an extra level indirection, except the problem of too many levels of indirection. And in terms of org design, and I have a radical opinion on that, is that usually QA teams have an extra level of indirection. QA teams don't solve a lot of problems. It is just that you can deflect blames, you can buy more time, and this is what's actually happening with QA teams, and I will talk about that. So when I've gone and talked to a lot of engineering leaders and I've asked them that why do you have a QA team, and I get a bunch of these answers, and I'm not sure if any of you have these answers, but sometimes people say that PMs do not have ability to toggle flags in the DB, they cannot install apps, download APK, they have to on their mobile they have to turn off things, security settings to download logs. They don't know how to do ADB logcat capture and all of that stuff. Again, excuses, I feel. I've heard people say, oh, my PMs are having iOS, I need QA for doing Android. I mean, you should really stop your engineering team and just shut down shop and not run a tech team at all if you think that way. There, I have heard people like PMs are looking at strategy, user research they are doing. They don't have the time to run the app and do QA testing. All of these things, if you are evaluating for this, these responsibilities should come to PM. PM should learn to do these things, and engineering should enable them to do these things. There are projects like Flipper and a bunch of log capturing tools that exist that can help you capture logs. Installing apps, you have TestFlight on iOS, Firebase app distribution via which you can very easily distribute apps. I'll talk about that as well, why that is actually needed. Toggling flags on DB, give them a dashboard, whatever they need. If you want to turn on and off A/B tests and all of that, PM should have the ability to do that, and they must have the capability to do that. If not, they are not a PM. I've heard, of course, engineers do not test thoroughly. We need QA to bulletproof. You tell the engineers that there is no QA, engineers start testing thoroughly. You tell engineers that they own the code, they start testing properly. As long as you tell people that there is a safety net, and that famous Batman Begins scene, if people remember that, where Bruce Wayne opens that rope that he was wearing, and he opens it and then he jumps. Because that I can jump only if there is no rope. And if your engineers are not happy doing this, you need L&D effort on your engineers. Engineers cannot think that my job is to write code and somebody will be testing this. Another thing is, like, if QA exists because there is no coordination between front-end, mobile, and back-end engineers, QA is the only person who can talk to all these three people and get and run this test. Again, you have org design problems. QA is not supposed to solve this. I've heard people say that we have compliance reasons, we need to have QA. I can sort of understand that. Sometimes clients need to be shown QA headcount if you're an agency. I have seen sometimes in fintech and all compliance which requires that. I don't have an answer for that. I've never had to solve this kind of problem. And of course, other companies have QA teams, also have heard. Just to give an answer to that, at Zomato, when we were doing 2 million orders a day, 5 million DAU, we had zero QA. At Target, larger scale than that now, QA team is getting retired. There was a QA team, they have been asked that they can move in product management, or they can go through 3-4 months of training and learn mobile development, and they can go there. QA team is getting retired. It has been 1 year I've left. I think QA team probably does not exist there anymore. These are fairly large teams. There are a lot of teams inside Google where multiple product teams in Google don't have any QA function associated with them. Vedic has a very good argument. Compliance requires you to do testing, doesn't need you to have testers. It can always be argued. I think you can ping Vedic about it. Very nice. Vedic has offered that. Coming to team design. Now, how do you team design after that modularization that I talked about? So I did that poll, and one of the reasons was like a lot of people say that they have mobile teams less than 5 in size. When do you need to start having pod-wise team design? Is I feel when your team size kind of increases over 5, then you need to have ownership on separate parts of your code. Before that, everybody can be responsible for the entire code base, and they might be working on different features at different times. It is okay if a pod contains one person. Of course, I mean, if you have heard Swanand's talk, he was talking about pair programming, and while pair programming, this might not be a good thing. Very important thing is that one pod can own 2 modules. You can make a pod which owns 2 modules. You can have store and order pod. You can have membership and support pod that you can do. Don't make 2 pods work on the same module. There has to be ownership defined property. So it can't be that there are these 2 pods which are working on store module. They are not 2 pods then. They are one pod, and they should have a Spock who an engineering Spock for that pod. Right. By Spock, I mean single person of contact. And how you create the pods, again, I recently made a tweet about this, and I think Ulhas is here. If you're an agency, you probably have to split it across functions. But if you're a product team, splitting it across business domains work much better. So you split on feature, or you split on sub products basically. And then the pod is not just the mobile team. The pod also contains the backend people and the front-end people and the design people and the product manager. So it's a pod which is working on that feature end to end, and they are responsible for the moving the needle on the business of that feature. Split pods per tech function I've written across there. Like I said, if you're probably servicing clients who are doing an agency, you might need to do it the other way around. But what also happens, I feel, is that sometimes you end up with 1 pod per client if you're running an agency. Then is a very important question. Is anyone here having a mobile platform team? It did not feel like somebody might be having, given the size of teams people reported. But do you have a mobile platform team? Now, to cover this thing, do you need one is a very important question. There is a certain scale beyond which some companies start needing a mobile platform team. Why you should have a mobile platform team, and what are their responsibilities, and how should you structure them? I should talk about it. Fairly at a scale when you have 50 engineers working, generally a platform team starts making sense when you have scale of the team, not necessarily scale of the product. And if teams have 40, 50 people working on the mobile app, I see platform teams starting to make sense. Now, a bad design of a platform team, and I mean, I have consulted with a bunch of like unicorn-sized companies in India recently, and I see that engineering is starting to give you trouble. Like apps is crashing a lot, build times are long, and product features are not getting pushed. So you bring in some senior people from old school app dev companies, like somebody like a Hotstar or a Zomato or a Swiggy or a Flipkart who has been doing app dev for 10 years. You bring in somebody with 6 years experience. You tell, okay, this person is my platform team lead, and then you give them zero power. And you tell them that, okay, move all my engineering metrics, increase my crash free rate, reduce my build time, all of these things. But your lead of your mobile team remains whoever was there. So your platform team is basically the janitors who will clean up after the feature teams have come and made all the mess. This kind of platform team is set up for failure. It does not work. So your platform team should do 2 things. Your platform team should be owning the bottom layer, and maybe possibly it can own the integration layer. So you have pods which are split across the business domains. Your platform team comes in, builds the tools that enable them to build things. So they create a design kit so that they can build UIs easily. They build a network kit so that they get a secure network library that can connect to your backend. They don't have to do any headache. Logging is done automatically for them. They focus on building the features. And platform team can take the responsibility of the integrating everything together and putting it on the app. Right. Again, platform teams should not be given directly just that, okay, the platform teams are responsible for reliability and performance, everybody else is not. No. Platform teams should have OKRs, which is to create cadence for release, create a process via which your let's say you want certain layers of your product to be. But actually, what is the process that will lead to that? Platform team comes in, creates that. Tools that you need for better monitoring, platform team comes in and builds that. Okay. The win for when reliability performance increases is for the whole team. It's not for just the platform team. Platform team is not like work in the shadows and make things clean. It's not how it's supposed to do. Platform teams, just like Vedic also said, like platform teams, like his testing engineer infra team is doing. Platform team can come and create the CI/CD infra, but platform team, you don't tell them, okay, platform team will do the releases. You keep building whatever you want. So that's, I mean, if you need a team which does these things, then build a platform team if you feel there's a need, but don't do it the wrong way. So that was about org design. We'll move on to processes. If any questions on this part, happy to take them up. Next is about processes. So, of course, this is, I don't know if Pratul has published his blog or not. Tramline, I think it is published. So go to tramline.app, and Pratul has written a very nice article on this. I don't want to go into too deep, but all good engineering leaders I have interacted with seem to endorse this. And yet, wherever I see engineering broken, usually run-based development and release trains properly are not getting followed. So, how many of you follow run-based development in your user-facing products? Oh, I don't. Okay. Awesome. So I have just 3 people. Some people are saying no there. So, of course, like Ulas and obvious, they're all doing that. So, what is run-based development? Like, it does not need to be as rigorous as like backend teams in mono repos like Google and all do, which is people actually directly merge always everything into master. You have a very close 90% run-based development where what you do is that you build a very short-lived feature branch. How short-lived? Ideally 1 to 2 days, max 2 days. So, and I will talk about this a little later as well, just coming back on this. But to create a feature branch, of course, it should not live for 1 week, should not live for 2 weeks. It should live for 1 or 2 days. And you merge into master, and you keep on merging things into master. And whatever is your release cadence, weekly, monthly, daily, whatever you do, of course, you can't release daily on Android or iOS, but whatever is the release cadence, whatever is the current state of master, you just make a release out of that. If you are not confident in making releases out of master, you need to ask yourself questions why about that, because creating a release branch does not improve stability, right? It does not change your team's DNA. So creating a release branch will not change fundamentally the reason why you're scared of making releases out of master. You might be scared of changes because it will be breaking and all. You have feature flags to control those kind of things. You need to have robust testing, CI/CD infra in place. But now this prevents you from creating releases from master. What about if I make a release and there is a bug in that, right? So the ideal way of doing it is that if you cut, let's say 2.2 release, and then there is a bug in that and you need to fix it. Obviously, that same bug exists on master. So whatever is the process of merging a feature, you follow the same process, obviously with a little bit of urgency because it's fixed. But you follow the same process and get the fix merged into master first. So that it passes the same procedure that everything else goes through. It goes through whatever CI/CD. Let's say you have manual QA, so it goes through manual QA. It goes into master the way everything else is supposed to go into master. You cherry pick that into your V2.1 and you make a 2.1. So this is the only place where the branch for a release you have cut might have additional commits. Ideally, and then we used to have this setup both at Zomato. I had moved into this kind of a setup at Target. We had this setup. Release branches, 96, 97% of them would just have one commit, the one on which we created it. Just one fork out of the master. I mean, you can go even hardcore and go and do it as a release tag on the master branch. But very rarely, 2-3% of the cases, the branch that has been cut out for the release has one hotfix, right? That ideally should be 0, but yeah, it will happen. Then a very important thing is, how do you version bits? Now, does anybody know top of their head the version of app they're using for popular apps like Google Maps, Google Pay, PhonePe, Paytm, Swiggy, Zomato? Anybody knows actual version you're using as a consumer? Do you care? A lot of people within the org think that their users care. They think that, oh, this is big stuff, we will go into V10. People try to follow semantic versioning and fail miserably in doing that. Somebody says, hey, this last release, we merged a lot of things. It must become V9 because V8, we can't say 8.1. Happens, keeps happening, I see. Your users really don't care about the APK version. Nobody knows, nobody cares. You then try to chase after, okay, V10 of Android and V10 of iOS must have the same features going ahead. Forget. You want to control feature rollout, do it via server-side flags. You put flags on your app, you ship the feature behind the flag will get opened. It will end up with a bit of if-else peppering up in your app and if-else peppering up in your backend. That's a part of engineering cost. It's not bad engineering those if-else clauses, because there is no such thing as semantic versioning unless you do shrink wrap programs. Like, people know which version of OS they are on, because OS is once shipped, it's shipped, and people don't update it every day. These days, that's also changing slowly. I mean, back in the day when internet used to not exist, Windows XP once released, then 3 years later, they can release Service Pack 2. Till then, they can't do anything. Why give your developers anxiety that, oh, this has not released in 9.1, this was supposed to go in 9.1, this will go in 9.2? Forget all. Just use build IDs, maybe use year-wise versioning, have some version number which makes some sense, but don't need to do semantic versioning, don't need to make user-friendly numbering. These apps that I talked about, go and check their version numbers. The Google ones have these long strings. They have some, 5567 dot 54 dot something, then hyphen some commit ID. That's how their version numbers are. You won't make any sense out of that version. Nobody needs them. Okay. Now, coming back to why you should have the processes set up for trunk-based development, and what sort of process I was talking about. Now, CI/CD does exist on my iOS. It's not like it does not exist. People say that, okay, you can't do continuous deployment. Okay, you can't do it to your users. You can't push a build every day to App Store, but you can do CD for employees, right? There is Testflight, there is Firebase Test Labs for iOS, for Android. Ideally, a process I've seen work very well is that one ticket is mapped to one branch, is mapped to one build, is mapped to one place. That place could be anywhere. It could be your GitHub PR comments. It could be your Jira ticket dashboard. One place where the sign-off happens. And that sign-off, there could be any number of stakeholders. Maybe the PM is a stakeholder, maybe the PM and the designer is a stakeholder, maybe you have a person who signs off on accessibility, there is a stakeholder for that. At Target, everything we used to merge needed to be signed off by product owner, by designer, by accessibility, and also by analytics. They need to check that all these things are working. But it has to be one place where all of this sign off happens. It can't be at multiple places. People have to chase that, oh, this person approved, that person approved, and you don't have visibility while merging. Whoever is merging, somebody would be, taking care of releases and all. So where will they look for that, this is supposed to be merged or not supposed to be merged? So first of all, scope your task. I mean, it could be Jira, whatever you're using, Linear, Asana, whatever. Your one ticket should be the sort of work that can be done in 1 or 2 days by one engineer, can be created as a build where it can be tested. That should be the scope. So for every ticket, the same name, you create a branch, create a CI/CD system that runs all your tests for that newly created branch and creates an APK and IPA file, which can be deployed to your non-tech people's mobile phones. So you install Testflight or FAD into mobile phones of your QA, design, PM people. They can basically install a ticket ID. I'm working on XYZ 345 ticket number. As soon as the dev said that I have finished the dev, I have done the build, all these non-tech stakeholders can install it by the ticket ID. They get a notification, ticket ID available, they can install an APK. One more thing I have to do, make the test apps with a different package ID and a different name and logo, so that it's easy for your employees to have the prod app from the Play Store or App Store installed on your phone. Plus, you can install a development version of it, which has a separate package ID and a separate logo to differentiate between the two things, and they can install it. They will install it, run it, they give a sign off, single place where all of these things happen, where any questions about specs and requirements, all the to and fro happen in one place. Communication place is one. Worst case, it could be a Slack thread as well. I would not recommend, but it has to be one place and everybody has to agree this is where we discuss things. So that's about some of the process things which I feel can obviously make you go faster. Do you recommend squash merge from dev branch to trunk or regular merge? I would recommend a squash merge. So that's the reason why I say this. So one ticket ID, you create one branch. The dev might do 2-3 commits for that, but that is one unit of work for my org, for my business. That can be scoped as a single ticket, which means that has to be merged as a single merge. Because at the end of the day, when I look at the entire master branch, each commit individually should mean something. They should be atomic in nature. It should not be that one commit, like when you look back at any of the commits, you pick up any one commit, it does not make head or tail because you have to look at everything. Yeah, Ullas has said the same thing. I'm a big supporter of, not just supporter, I mean, I would, if I had a choice, I would refuse to work somewhere where you don't do squash merges. It's very important for having squash merges. And easier to roll back and everything. So finally to testability. And on testability, I'll cover like your ratio of unit integration tests. Should you write snapshot tests? Some things that enable better testing for your stakeholders. Right. So very first of all, I was recently having this discussion with Swanand only, and he was talking about writing tests and all. So TDD is very important. On mobile especially, one thing is like integration tests are a little costly in terms of resources because it has to be done on an emulator and all. All of those things, there are a lot of good solutions available. There is, Firebase Test Lab, there is AWS cloud devices. You can, sort of splice your tests so that only the tests on the module that you're working will run. There would be a little bit of R&D that your team has to do to get there. But the point is that when you go unit test heavy, your team ends up writing a lot of tests for the sake of writing tests. And you end up in situations, and I've seen in a lot of teams where I've got 100% unit test coverage on my business logic layer. People end up with that, heavily complex clean architecture model where their domain layer is pure logic and domain layer has 100% unit test coverage. And on prod, bunch of things are broken. This and that, lots of flows are not working, but my unit tests are working. You don't want to be in that situation. You have written a lot of tests without getting any actual benefit of that cost of writing those tests. And what happens is a lot of junior engineers, they are loving it. They are writing tests. They write one function. They write 20 tests for that. Different cases it's passing. But the idea is unit tests really don't help. You will have to go up the ladder. You have to write integration tests. On mobile, I feel writing end-to-end tests is a little harder because things change, and then there's the next slide. But integration test is a layer where you attack. Write integration tests where at least flow of state you are testing. Right? Maybe not how it looks on the screen, but at least the flow of state you are testing. That has to be tested. Now, a very important discussion here is about mocking versus faking, and again, might be very unpopular opinion, but I personally prefer that if you have tests which need hitting real API, that's also fine. Real API means maybe not the prod API. You have an API for test, which is a turnkey environment created from backend. Obviously, it's not responding with hard-coded JSON files. It should be an actual backend responding with actual business logic, right? There are a lot of good teams. Like I know there are teams within Google who do this. I know there is Uber. I know there is Slack. I know there is Square who do these things, and these are some of the best mobile engineering teams out there. They have for every test that they run an entire server for them. So they basically are running like their own API gateway or the BFF layer. The BFF layer, it's not sending them hard-coded JSON. It's actually fetching data and sending. They are protecting it against PIIs, anonymizing data, and all of that stuff. And obviously, it's not going to be writing through to prod DBs and everything. But it's actually APIs they're testing against. It's fine to do that. You test it on a test lab kind of device. They have network connections. So test it properly using an API. Don't hard-code any JSON files inside. Like, if you ever have response JSON files hard-coded in your repository on which the app is and you're testing against that, completely defeats the purpose. Tomorrow your API will change, and if something breaks, you will not detect it at CI layer. There's no point of writing those tests. So what I feel, we might have different opinions, but yeah, very much on a like against faking completely and mocking via real implementations, not hard-coded JSONs anywhere. Then there's something called snapshot testing, which is like you run the device, run the app, and you take a screenshot of the UI, and then you match it using either there are matchers, or you match it using actually very black box type, which is you match it using computer vision algorithms. And there are a lot of tools which do it. I think this is something that you don't really need to do it unless pixel perfect UI is very important to you, and you are at a very stable place in terms of UI and UX of your product. If you are still iterating on product UX a lot, you have a lot of motion layout stuff happening, which snapshot testing can't even test, which is like a lot of animations on the screen happening. Then let it be. Do it by manual testing. That's fine. I mean, manual testing, not actually having QA team. Developers will test it themselves. Product will test whether it's up to their liking or not. You might be able to write automated tests for accessibility. It's easier to test it, and there are, by the way, this is done for free. If you upload an app on Android App Store today, accessibility tests are done for free for you. Wherever there are too small text or context does not match, Google flags you. If you use the alpha beta release cycle thing, then when you release it on beta, Google does this test for free on 10 devices for you. Use that. Okay. Then there's the debug drawer. How many do you have? So there's a poll. We have automated tests in place as a poll. I want to know on the chat itself, how many of you have debug drawers in your app? A debug drawer is like you slide out a drawer from the right side or somewhere in your app, and in dev builds, you can change certain settings of your app. Not a lot of people seem to have it. This is quite a superpower to have it. I mean, you can, of course, push this back into a dashboard on the server side. Like you can say that for this user, give them this feature, stuff you can do. But on consumer apps with a lot of moving pieces, I feel having one is very good. So generally what kind of stuff happens here is you can change the, Ullas, any insights on why you don't have it anymore?
I mean, right now we are on client apps, so clients normally we haven't done it, but back in the day when I was using like coding an open table application, so we had this like Easter egg where we used to have in drawer and stuff. So that time we had it, not anymore.
Okay, understood. Okay, some people I see, Shuja and Vedic, they're saying they have it. So you can do is like assume the current user to be on test or control group, or use as a different user ID, these kind of things. Feature flags if you're having across your app, which you should have, and without feature flags, you can't do trunk-based development. So enabling and disabling feature flags is going to be here. So your non-tech stakeholders can enable the feature flags, see the feature working, it's easier for them to test. And also for engineers, you can turn on off certain things, like you can like memory leak, catching memory leaks, profiling, a lot of logging infra. You can actually disable that for better performance, and you can enable it only when you want to catch that certain thing. Like a lot of tracing things will slow down your dev builds. You can disable those things only when you want to trace a certain flow. When you run that flow, you turn it on, so you can do that. It's a popular thing. A lot of large-scale B2C apps use it. You can start having one as soon as possible. Have it over time, you will keep on adding things to it. It becomes easy to maintain this feature flag based thing. So feature flag is the biggest reason why most apps have it. Okay. Now coming to actually that whole diagram I was talking about earlier. Now enabling manual testing, and this is something I have seen a lot of good tech teams put in effort and putting a lot of thought into, is that you will have to test a lot of things manually. Even without a QA team, your engineers will have to test it. One of the things is like having engineers to test it is going to lead to what solution I'm talking, because the DNA of an engineer is that they don't like to do repetitive things and they will try to create ways to automate it. It will start off as people creating these scripts which launches an app at a certain state so that they don't need to go through this whole journey. But let's say you have this journey. It should be possible. Like if you create some changes in the checkout page. Now what will happen is, to test that out, somebody has to come in through Splash, then either they're logged in, they will end up at home. If they're not logged in, they might have to log in and come back, then go to shop, then go to cart, then they'll come to checkout. So probably the time to test would be 2 minutes, and out of which 1 minute 30 would be to reach that place, and 30 seconds to actually run manually test what's the problem. The more friction you have here, what will happen is, whether you have a community or whether your developers testing themselves, they will not test. They will make some small change. They're like, yeah, this will work, and they will not test. It's human nature. It happens. To make it easy to reach the checkout state. So the idea is, create entry points. Make it possible to launch the app at checkout page, launch the app at support page, launch the app at home page. And as you can see, home page can come from Splash, from login. If you come from login and from Splash, there are different things you see in the home screen. Make it possible to launch it in both these ways, using 2 different scripts or 2 different ways to trigger that. Right? You can set up your run configurations in your ID to launch the home page as post login, as post Splash. You can do that. You can create a script file which can do this for you. You can create a companion app with your main app, which triggers launching your app at these steps. We used to have a deep link launcher kind of a thing in Target, which was not a separate app. In the dev app, it was just shipped as a separate activity, with which we could launch our app in different states. You should be able to launch support. Support should need the user ID, what product they need support for, which page they came from, all these as parameters. Fine. You create a way to add these parameters and trigger the support activity. So that, again, you put in effort into make this a pure state machine, it's possible to do all of these things. Because if it's a state machine, you can start from any state, right? You just have to provide the input that's required for the state. Once this happens, you will see your turnaround time for testing reduces tremendously. Your developers would be happy to test everything themselves and push changes. They will actually be testing them properly. All of your stakeholders, your PMs, your designers, your backend people, it's easy for them to test. Like a lot of times what happens is, the app developer makes something. It has to be tested by the PM, the backend developer, the designer. Why not make it easy for them to test? So enabling manual testing, or to put in engineering effort in to make this possible. Once this happens, all of these four sort of the trunk-based development is possible. Enabling feature flags are there so that you can do these things. All of it fits into place. Chucker for network inspection. Tanju said, yeah, that's okay. We're talking about Flipper. So there's Flipper and there's Chucker as well. So you can check other things as well, not just network. You can check any logs. And you should actually believe in logs are events. Logs are not some println statements. And then something like Chucker is very helpful. So that's about it. The content of my talk is done. I would refer a few things. Yeah, Ulas, you have anything?
Yeah, so since it's a topic of setting up mobile production teams, right? So what I've seen is that a lot of apps these days are like web front end and back end first, and then the mobile app is an afterthought, right?
Yeah.
And then the mobile app comes later. So what I've seen is that the way the development happens on the front end and back end is completely different than the way it is required to mobile. What I'm trying to say is that let's say there's a change in the API, so it's easier for the front end team to accommodate those changes because they can deploy it faster. But with mobile, the deploy time is slower. The cycle time for each app update on the mobile phones are slower, right? So they don't really consider the backward compatibility of APIs a lot. when you're trying to set up the mobile engineering team, right?
Correct.
That is something I've started consulting people. I mean, whenever I step into, let's say, a mobile application, the first thing I ask is like, how is the backend team setup? And this normally is in the range of org design, wherein the kind of development that is required for a mobile backend is completely different than it is required for a front-end backend.
There, like I have seen moderate to very good success with sort of having BFFs or separate endpoints for mobile, because at least at a the million user sort of scale, I have never seen people being able to get away with same API for front end and mobile.
Right, and it also abstracts the whole microservices backend out, because then the mobile team can abstract things out and can run its own view codes. Whereas if I want to break down user service into multiple things, I can do that if there's a BFF involved. Plus things like feature flagging, or else even force update. Like for example, for a mobile app to function properly, I need a minimum version for the mobile app to be on, right? So all these things can work if there's a good BFF setup and like these hygiene are in place beforehand itself. So just wanted your opinion on that, and how have you seen that?
Correct. So before that, for everybody, I mean, this is a very good book to read, Building Mobile Apps at Scale by Gurley Oros. And also I will just keep this other thing on the screen, which is some good blogs which tech teams write about good mobile engineering. You can follow these as well. And that's a very good book. I think there's a website, mobileatscale.com, where you can get that. Coming last to your question. So I've seen it very quite larger teams, like sort of Uber sort of teams I've seen is that a lot of times whoever is your mobile engineering leader, like the VP sort of person, they have a backend team under them as well, who is actually responsible for the BFF. So the scope of mobile in some larger cases. Now, while it's at an org design level, but at a smaller case, what will happen is that your mobile team needs to start having some ownership of the backend. That can start with at least specifying the specs and not coming at the backend with vague things like, okay, how do I, update the app from a certain minimum version, and then asking the backend people to come up with a API response as a solution to it. Rather than that, you at least start owning the requirement side, that okay, this is the API sort of I require, the other things I need inside that API. From there, you can grow to having people in the mobile org who are responsible for maintaining at least the BFF kind of thing, which can come later, right? But yeah, I mean, your mobile team, there is one pitfall I've seen happen is a lot of times mobile teams, because the way the org treats the mobile team, they think that, okay, this API is sacrosanct and this is God. I can't question God and I have to use this API somehow. And then they will create a lot of hacks on the app side. That will never work out, because the same thing, you can never push an update on the app synchronously to all of your users and all that. So those constraints, you have to work within those constraints. Versioning of the API for the backend for your app, those kind of things you will need. A bunch of if conditions based on what app people are using, different responses going, those kind of things will end up happening. And obviously, you will run out of a runway of doing the same API for front end and for mobile. You will have to have a separate API for that.
Yeah, so this is what I've started consulting people as well, like seeing this practice.
Yeah, I mean, BFFs are great. I mean, you can start off with a BFF, which basically is a CDN to your actual API. And then you piece by piece take endpoints and actually add extra processing logic onto it where you need. Like step one is it's simply a CDN to your main API. That's where you start from. But then you separate out the endpoint, and then you can make changes to it wherever you need.
But if the app is making a lot of calls, then the BFF acts like a server to server call, so that's much faster than the app making all the calls and getting the data, right? So
yeah. Of course. And if you have microservices or even macro services, then having a BFF is definitely a boon to everything. You stop a lot of things go into your service layer.
I've seen a lot of organizations moving to GraphQL as a BFF. Just like they wanted to try GraphQL, plus it acts like a BFF as well. So that's kind of like a middle in between.
So that's an important decision to take. What I would say is that is your like the user flowing through your app, would it be very much like the REST APIs, or do you need like multiple depth queries? Do you need multiple? Do you need to hit the same endpoint with like depth 1 and sometimes with depth 5 as well? If that's happening a lot, then only go for GraphQL. But otherwise, like the ecosystem on the client side in terms of caching, retrying, backoff, all of that stuff that exists for REST APIs is still massively superior to GraphQL today. So that way, I mean, you have to do a lot of extra engineering work on GraphQL when you hit the corner cases.
Right. That's okay.
But serialization also breaks, so that's also a thing. Like with GraphQL, what happens is one of the deeper objects, it comes out with something else, and depends on what sort of serialization library you're using on the front end. There are libraries which can crash because some extra key came out in the object from coming from the backend. Anybody else has any other questions?
Okay. Right. I think, yeah. Thanks so much, Arnav, for this talk.
Yeah.
It's very useful. I think a lot of folks have taken good notes.
Yeah. Thank you for having me here.
Thanks very much. All right. Bye, everyone.
Okay. Bye, Pidi.